introduce the concept of a Venn diagram and how that helps understand set operations. And so here I've drawn several different Venn diagrams, and a Venn diagram is simply a pictorial representation of a set. So it's just a picture of a set, something that helps us visualize what's going on here. So in particular, here in this first one, I have a set A and a set B, and you see they have some sort of overlap. Okay, now if I consider this portion of the set, which is all the stuff in A as well as all the stuff in B, that set is represented like this. And that's read as A union B. And what that means is everything in A or B. So if anything is in A or B, it's an A union B. Now, secondly, if I take this same picture, so I have A and B, and this time I only want to look at the overlap here. So what's in the middle? Okay, so I write that like this, and it's read A intersect B, the intersection of A and B. And what that means, it's the stuff that's in A and the stuff that's in B. So for this first one, if I said let's let A be the set of mammals, and let's let B be the set of North American wildlife, okay, then A or B can include anything that's either a mammal or North American. Okay, so over here I could have a giraffe, which is not in North America, right? I could also have a rattlesnake, which is in North America, but it's definitely not a mammal. And then I could have also the stuff that's in both. So for example, the bison. That's a North American mammal. Okay, but as long as it's in any of those categories, it's in the A union B. Now for A intersect, I could do the same thing, and this time the giraffe is not included, the rattlesnake's not included, but the bison is. It has to be the stuff that's in both. We have the opossum, right? We have the bison again, the chipmunk, and other things as well, right? Okay, so this would be A intersect B, would be North American mammals. All right, now this last example here I have A, and what I want to actually do is consider the things that are not in A. So I want to consider this part. And here I have to have some sort of parent set outside of A, okay? And this is written as A bar or A apostrophe or A C, depending on your textbook. And this means the A complement. This is A complement, and this means not A. So the stuff that's not in A. Okay, so here, if we let A be mammals again, to follow our example, this would be like the roundworms, fish, etc. Okay, any animal that's not a mammal. Okay, now as an additional example here, let's let set A be 1, 2, 4, 5, and set B be 2, 4, 6, 8, and set S, which is our parent set, be 1 through 10. Okay, so then if I wanted to look at A union B, that's the stuff that's in A or B. So 1, 2, 4, 5, 6, and 8. These are the things that are in A or the things that are in B. Okay, now if I want to look at the intersection, this is the stuff that's in A and B simultaneously. Okay, so here 1 is left out, but I have 2, 4, 5, 6, and 8 are left out because 2 and 4 are the only things that are in both. If I wanted to look at A complement here, that would be the stuff that's in S, but that's not in A. So that'd be, let's see, not 1, 2, 3, not 4, 5, but 6, 7, 8, 9, and 10 are all part of A complement there. Okay, now in algebra, you may see something more like this. Here I have the interval -2 to 4, union the interval from 0 to 9. And I want to know what the union of that is. Okay, so the way you could do this, okay, let's take a number line. Here we go, going from -2 up to 9 somewhere, okay? Let's say here's 0 and here's 4. And my first interval was -2 not included up to 4, or 4 included, something like that. So you have that. The second interval was from 0 not included up to 9, with 9 being included. And now when I look at the union, that means the stuff that's in one or the other, okay? So if that's the case, then I know that -2 all the way up to 9 is that union, right? With -2 not included and 9 definitely included. So the union of those two intervals is another interval, -2 to 9. If I wanted to do the intersection, I can just look and pick out the part that is only dealing with both of them. So that's from here to here. With the 0, carefully, the 0 not included, right? So that's up to from 0 up to 4. And there's your answer. Understanding basic operations of sets is very useful, not just in algebra, but it's also useful in statistics and calculus and other places. If you have any questions on this, I'd be glad to help. And thanks for watching.